been looking at motion graphs and started off with a speed time and velocity time graph comparison to show you, how the two are different. So we had a ball that was approaching a wall at 3 meters per second. It takes 2 seconds to go towards the wall, it takes 2 seconds to come back to its original position. So 4 seconds in total, always traveling at 3 meters per second, which is obviously not, what's going to happen in real life. It's going to slow down at some point, but we'll just imagine for the purposes of this example that it's a uniform velocity towards the wall and back. So if we're drawing a speed time graph of that motion, our speed the whole time is 3 meters per second, and it takes 4 seconds to complete its motion. We'll imagine it stops at that point, its original point at the end. But if we're looking at velocity time graph, remember that velocity is a vector, so we have to take into account magnitude and direction. In order to do that, what we do is we assign a positive direction to one of our velocities. In this case, we took positive as being in the forwards direction, and we took negative as being in the backwards direction. So when it goes towards the wall, it's travelling at positive 3 meters per second. When it bounces back from the wall, it's travelling at negative 3 meters per second. So we assign a sign to it, positive or negative, to tell us which direction it is going in. We then looked at how to calculate the area under a graph, or to calculate distance and displacement. So the area under a speed time graph gives us the distance travelled. So in this case it's 12 metres, 6 metres towards the wall and 6 metres back. For displacement though, that takes into account direction, so it's the area under the velocity time graph, where the displacement is 0 because it's returned back to its original starting point. One more thing we can figure out from velocity time graphs as well is acceleration. So here we've got a starting speed of u and a finishing speed of v. If we take the gradient of that over an interval of time, we get v minus u over t. So the gradient of a velocity time graph we can use to calculate acceleration. It works the same way for a speed time graph as well, and just take 2 points on it, calculate the gradient, that will give you acceleration. So velocity time graphs take into account direction and magnitude, and we can also use them to figure out acceleration by taking a couple of points on the line.